Hello there, I Dr. Anuj. Today we will discuss bridging mode in metal hydride complexes. In last lecture we have already discussed about metal hydride complexes, their introduction, their synthesis, their acidity and basicity applications. We have already discussed. You can find those videos from description box. Okay. Today we are going to discuss bonding mode of MH bond. Okay, that means in metal hydride complexes, hydride can be terminal or bridging. Okay, so this bond can be in two different fashions. One is when this hydride ligand attach with metal, only one metal, then this bonding is known as terminal bonding. Okay, this is terminal bonding. And if you look, here is hydride ligand that have one lone pair, that is 2 electrons. So these 2 electrons involves 2 centers. So this is 2 centers, 2 electron bonding, and this bonding is known as terminal bonding. Okay, terminal bonding. And another bonding is that when this hydride, which have one negative charge, that means 2 electrons attached with 2 metals. Okay, so you can say that these 2 electrons involves 3 centers, 1, 2, 3. That means 3 centers, 2 electron bonding. This bonding is known as bridging bonding. Okay, this is bridging tendency, bridging type bonding. Okay, and you can represent it mu2 hydrogen bonding, because mu2 mean this hydride attached with 2 metals, so that's why this represented a number mu2 hydrogen bonding. Okay, this is mu2 and 3 center 2 electron bonding. Another thing is that if you have another complex, just like here, this hydride attached with 3 metals, this metal, this metal, this metal, these are attached in this fashion. So this hydride attached with this metal, this metal, this metal. So this is mu3H bridging bonding. And you can say that 2 electrons, because this hydride has only 2 electrons, and these 2 electrons are involving this metal, involving this metal, and involving this metal too. So that's why these 2 electrons involving between 4 centers, 1, 2, 3 and 4. 4 centers involving these 2 electrons. So this is 4C 2 electrons bonding, and it will represented by mu3H bonding. Okay. Another example you can say, you can take just like this. You can take an example just like octagon structure or octahedral fashion. Just this is metal or closure type structure, right? Maybe. So this is metal framework, and here is one metal more, one metal. This is metal, and this metal attached with this, and these 2 metals attached also this. And if there is one hydride ion present in the center of this framework, then this hydride will attach with this metal, this metal, this metal, this metal, this metal, this metal too. Okay, so overall you can say that 2 electrons, because hydride, this is hydride ligand, and this has 2 electrons. So that's why you can say that 2 electrons involving on 7 centers, because 1, 2, 3, 4, 5, 6 and 7 itself. Okay, so this is involving 7 center 2 electron bonding. Okay, and what about bridging point? You can say that this hydride involving attached with directly 6 metals. So you can say this is mu6 hydrogen bonding. Okay, this is mu6 hydrogen bonding. Okay. Now, so this is all about the bonding mode of MH bond in metal hydride complexes. There is one point, that which one hydride will be more acidic and which one will be less acidic. Okay, because this is terminal metal hydride and this is bridging, also bridging, also bridging metal hydride. But our question is, if we make a compare between all metal hydride complexes, and then we need to decide if we try to make a acidic order of these hydrides, how can we make? So you just need to remember that this hydride will involve only 2 electrons, and as number of center atom involving center atom will increase, the electron availability due to hydride will be decreased. If electron density decrease, then it cannot attract the proton, its conjugated base. I am talking about its conjugated base. Then its conjugated base will not attract the proton efficiently. So that's why its conjugate base will be weak base. If conjugated base is weak base, then conjugated acid, that is metal hydride, will be a strong acid. Okay, let's try one more time to understand this. This hydride involves 2 electrons in every cases, and you can say here is one center, here is 3 center to involve 3 electrons, here is 2 center to involving 2 electrons, here is 4 center involving 2 electrons, here is 7 centers involving 2 electrons. And the availability of electrons on each center is going to decrease as number of center involving 2 electrons, that means involving hydride ion, is increasing. So that's why their conjugated base will very poorly attract the proton from the solution or reactant species. So that's why their conjugated base will be weak base. So that's why their conjugated acid will be more strong acid. Okay, so that's why it will be strong acid as compared to this one, and this one is a strong acid as compared to this one, and this one is more strong acid as compared to this one. So you can make a concept that acidity directly proportional to the number of center involving H negative ligand. Okay, so that's why you can say that mu6 will be more acidic as compared to mu4, and mu4 will be more acidic as compared to mu2. Sorry, it is mu3, right? Yes, it is mu3, and this is more acidic as compared to terminal metal hydride. Okay, so this is all about the bonding mode. There is one point is also considerable. You can say that electron donation availability, because we will discuss some chemical reactions where we will study the effect of electron donation of ligands. So we are going to discuss the effect of some types of electron donor ligands. Okay, some types of ligands. Okay, to decide the ability to donation the electron density to the metal of ligands. Okay. So here is 3 types ligand. You can say easily that one is electron donor, directly electron donor, and one is pi donor, and another is sigma donor ligands. Okay, electron donor, you can say if metal attached with heteroatom just like nitrogen, oxygen or halogen, this is lone pair donation to metal. So this is electron donor ligand. And if metal attached with any pi system just like ethylene, cyclopentadienyl or any pi electron density involving molecule, then you can say that it is pi donor ligand. And sigma donor, just like here, this is hydrogen, this is hydrogen. So this sigma bond will be donated to metal. So this is sigma donor ligand. H2 act as a sigma donor ligand. And the ability to donate the electron density to the metal from ligand will follow the following trend, that this electron donor will be more efficient as compared to pi donor, and pi donor will be more efficient as compared to sigma donor. And these concepts we can apply in chemical properties of metal hydride complexes. In next lecture we will discuss about the chemical properties of metal hydride complexes. Okay, we will study the chemical properties, we will study a lot of mechanism in next lecture. Also we will also discuss some spectroscopies characterization of metal hydride complexes. Okay, and after all we will discuss some last year's questions which were appeared in NET, GATE, CSI exams and other competition examinations. Okay, so we will on the basis of metal hydride complexes. Okay, so we will discuss all about. Okay, thank you for watching for this. Next lecture will be on chemical properties of metal hydride.